Good evening, everybody. Hi and welcome to LambdaLounge. So we've been doing a little bit of a Lisp kind of mini season, and oh dear, I've got myself in my excitingly, I had myself in my headphones there in YouTube. This is a highly slick and professional event, as you can see. So we're doing a little bit of a Lisp mini season. Last month we had an implementation of a Lisp in Elixir, and this month we have Veit Heller, who is one of the core contributors for the Carp programming language, which is a Lisp which we've previously talked about at LambdaLounge. Now Veit describes himself as a jack of all trades but a master of none. Now I don't believe that for a moment, as I've spoken to him, and he's very expert, so I'm hoping this is going to be a really great session. So Veit is interested in compiler development, writing, generative art, and you can hire him as a technologist at large. Connor, can we have the next slide, please? There we go. So please do join us on our Discord chat. That's the link there. You can also leave comments on YouTube, and whether you speak on our Discord chat or YouTube, or indeed the Gitter chat for the Carp language, we'll try and keep an eye on those and relay questions to Veit during the talk. Is another slide, Connor? And no, that's for later on. So let's go on with the show, and I will invite Veit onto the stream. Veit, lovely to see you. Shall I add your screen on now?
That would be lovely. Thank you.
Brilliant. So thanks very much for joining us, Veit, and I'll see you later on the stream. Take care.
Thank you. Thank you for having me. Hey, everyone. I'm now in front of my terminal. In fact, it's two terminal windows, and I'm just gonna, well, first, maybe I should introduce myself. So I work on the Carp programming language. I mostly do a little bit of compiler development, but I mostly shepherd the standard library and a few libraries around that. And that's it about me, really. What is more interesting is maybe the setup. So I have two terminal windows open. One has a Carp REPL, and the other one has a file open in my favorite text editor, Vim, that is now empty, but it's called brainfck.carp. And so if I save this file now, I can load it over here because, well, they're both in the same directory. And because it's empty, it's not going to do anything. But we have loaded it, and now what we can do is we can reload the file with :r. So whenever I do :r, or when I forget to do that, the things that are in the editor will be updated or not. :r is just a shorthand for reload, and the documentation for reload you can find here. All right. So with that out of the way, maybe we should talk a little bit about what Brainfck is. Brainfck is an esoteric programming language. It's based on the Turing machine, which Alan Turing famously used to prove some conjectures about the halting problem, namely that it's unsolvable. A bit after Alonzo Church, but I think it was Kurt Gödel who said that that proof was better. He liked that more than the lambda calculus. Now, I don't agree, but the Turing machine is a very nice model. And how it works is that you have an infinite tape, and it has an alphabet. In the case of Brainfck, it's bytes, but it could also be binary, or it could be, an alphabet that we know of. And then we have a head that goes over that tape and can read one value or write one value at a time and compute like that. The instructions are for that read-write head. Now, infinity is hard to come by, so in Brainfck, usually the tape is 30,000 or so elements long. I think 30,000 is actually the canonical thing. And we have 7 instructions. We have 8 glyphs, but one of them, looping, uses 2 glyphs, but it's actually just really 1 instruction. And the instructions that we work with are plus, which increments what's currently under the tape head. So if there's a 0, we will add 1 to it and get a 1, and so on. We have decrement, which will do the opposite. It will decrement the value. We can move the tape head forward. We can move the tape head backward. We can print what is currently under the tape head as an ASCII value to the standard out. We can read whatever is in standard in, the first character, and put that into the cell under the tape head. Cell is another word for that little thing that we have. And then we can loop. And the way that loops work is, well, you have a body here and they're delimited by these brackets and you can nest them. But basically what happens is when I hit this bracket, the opening bracket, you will get, it will check whether the value is 0 or not. If it is 0, the value that's currently under the tape head, then it will jump over the loop. Otherwise, it will continue to the end of the loop, execute the body, and then jump back to the beginning and check again, is the value that's currently under the tape head 0. And we'll do that until it isn't. It is, and then jump. Yeah, so that's all we need to know about Brainfck to write our compiler. But to write a compiler at first is maybe a little bit tedious. So let's write an interpreter first. And to make that easy, what we're going to do is we're just going to write a very imperative, very unsafe interpreter. And we're not going to implement loops at all, because that's, the easiest thing that we can do. So the first thing that we will do is we will create a tape. And to do that, we say array replicate 30,000 times the byte 0. You hear my cats in the background, maybe. The little ampersand here is for references. Carp has a lifetime system. That's very similar to what you have in Rust, but that really doesn't matter much for what we're doing today, just as a heads up. So you have a byte literal here, as noted by the byte B symbol at the end. And then what we're going to do, we're also going to define a head that can be an integer. I'm going to call it HD because head is already used to take the first element of something. And we're going to actually use that. But what we're going to do is, while the string is not empty, we're going to let do take that first thing, the character, which is head of S, and then we're going to case on it, that character, and then we're just going to say, okay, plus, this is what the literals look like for characters. They have this little backslash in front of them. And then we have an else branch, and that doesn't do anything yet. The case statement isn't done yet. I've just added the cases and not the bodies. But I want to write everything that we need to do first, the skeleton, and then we can continue. And then we just say S is the tail of S. And I already know that we will have to do a bunch of fiddling with lifetimes here and so on, but I will get to that when we get to it. So incrementing something is as simple as updating what's under the array in place. And maybe at this point we should look up what that does. I actually made a typo here, array update. And well, there is a little bit of a documentation, but if we look at the function, we see that it takes a reference to an array. The lifetime doesn't matter, but it takes a reference to an array, an integer, and a reference that takes a reference to function that takes a reference to a thing and returns a new thing. Due to the references, this is a little bit hard to read because of the lifetimes, but it is relatively easy once you get the hang of it. So we're going to take a reference.
So Veit, it just occurred to me that while you're talking about lifetimes, that if you're thinking of this as a Lisp, and obviously it looks very much like a Lisp, a lifetime isn't necessarily a very familiar concept. And I know some of the people watching may have attended our talk on Carp, but I wonder whether maybe not now, but maybe at some point that would be a really interesting concept to look at. For
sure, yeah. I think it is good maybe to get an intuition about that. So a lifetime is basically in a type signature, it needs to be unifiable like any other type, so that you can say this thing cannot outlive this or that. So basically it is a scope as a variable. Like you can have type variables, you have scope variables where you say this has to live at least that long or at most that long. And that's what a lifetime is roughly. So the lifetime of a reference says how long is that reference alive for. That makes sense.
Great, thank you.
Cool. All right. So if we continue down that track, we have to provide an update function. And sadly, I can't just pass inc, which is the incrementer in there, because again, it takes a reference and we have to copy. But all of that is just tedium. All of that is just little bits of glyphs that we can mostly ignore, and that the compiler will actually warn us about if we get it wrong. And then you just bang and ampersands and ats at things until it works. That's how I started anyway. Maybe some people are more principled than I am. But yeah, so all we are doing here is we increment and decrement what's currently under the tape head. And here, what we do, we increment and decrement the head, which is the index, directly. And if we do that, then we already have all of the primitives that work with the tape directly. And now what we're going to do is we're just going to add period and comma, which is input and output. And they're, again, a little bit weird because it's all characters. So you will have to stringify the character from the byte that is currently under the tape head. And for that, I'm going to use unsafe nth because, as I said, this is going to be just a little interpreter that we can work with that's, well, unsafe. But that is going to give us an idea what, this will look like. All right, that could work. I think this needs another ampersand. And then here we'll have to set, that's like array update, but instead of an update function, it just takes a value. What the value is going to be char to int io get char. That was my doorbell. Okay, all right. So with that out of the way, we have an interpreter, maybe. I'm going to just save the file, and maybe Carp is going to scream at me. It actually probably will at this point, yes, because we're using s in an inconsistent way. And this will get back to whether something is a reference or an owned value, because empty takes a reference, and head takes a reference, and tail takes a reference, but tail returns a string. So we have a choice between either making s a reference or not. And I'm just going to say, for now, we're going to make it an owned value, because that's the first thing that came to my mind, I guess. But yeah, so that one is fixed. And the other thing is, that I put in the wrong glyph here. Boop, 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 and that should fix that. And then here we need to add another ref, and then we might be good to go. No, still no. Inferred chart to byte. But all of this is relatively simple for now. the semantics of Brainfck are simple enough that they fit on a piece of paper. But what we can do now is we can interpret stuff. And I just happen to know that the 10th ASCII symbol is one of the new line characters that we have at our disposal. So I'm going to just increment 10 times in an output, which will put the ASCII symbol 10 into the first cell and then output. And that should lead to a new line being printed, and that is correct. So we know that it kind of sort of already works, probably, maybe. We can also, increment the cell before and it should still work, and then maybe increment the cell again and decrement it again and it should still work. And it does. So our Brainfck interpreter works. But that's not what we came for. We came for a compiler. And this is where I will put in a little bit of sleight of hand and show you how to make a compiler that is almost equivalent to what we just did. So the compiler will be relatively simple. We're just going to make a macro that compiles so that we can leverage the Carp itself as a compiler. And we're going to emit Carp code. And we already know which Carp code to emit because we know how to write an interpreter for the program. So what we can do here, and I'm quasi-quoting here, and I will explain what quasi-quoting is in a second for those of you who are not necessarily Lispers. I think most people here might probably have encountered Lisp, but still, I'm not going to leave those of you that do not have that experience behind. But I'm just gonna, for now, what you can think of this as is a little template where all of the green stuff is just the template. And then if we put in these glyphs, what they're going to do is they're going to unquote something, is what it's called, and put that in as as the expanded value. And so I can say map compile char, and I have to say string to list here, just because map takes a list. So I'm going to do that, and then I have to define compile char. So I'm going to explain, though, actually that takes a char. I'm just going to return char and explain quasi-quoting a bit more. Basically, quoting in Lisp is a way of making, a list as a data structure, as opposed to a function application. Now, quoted values are not expanded. So if I put an X in here, it's going to be the symbol X and not if there's a value associated with X. If I bound X to 1, then maybe I want 1 in there. So that's where quasi-quoting comes in, where I use a backtick instead of a tick. And then I can do this, which is the same as the above, but I can also do this, which will unquote the thing. And I can go even further if X were a list and I wanted to splice that list in. I could use this glyph, and that's what's called unquote splicing. So for those of you who are familiar with that in other Lisps, you might know almost all of those symbols except the percent, which in Clojure is in tilde, and in Scheme and Common Lisp is a comma. But other than that, it's the same thing. You just read it, and all of it is quoted except if you encounter something like that. Fun thing about that is that it's also just a macro. I implemented that just a while ago, and it was actually very gratifying to add. I wrote a blog post about it if you're interested how to do that. But yeah, so what we're going to do is we're going to case on the character. Again, already you can see, hey, this is very similar to what we do above. And, because it's so similar, let's just copy paste it. And actually go in here. And one difference is that string to list, what it will do is it will return instead of a character, a string of length 1. But that doesn't matter much. What's more interesting here is that we have to quote all of this. And when we've quoted that, we're already almost done. And there is this problem now here with the green being expanded a little bit too long. And that's, I think, because I messed something up with the syntax highlighting in Carp. I wrote the syntax highlighting plugin for Vim. So that's me. But just forget about it. The green should stop basically here. So if we add this, what will happen, and I can show you that maybe on the other side. Oh, actually, I did something wrong here. Trying to, this is defn, but it should be a dynamic function, which is a function that I can use inside a macro or at compile time. And then this goes away. So if I reload now, and we will inspect what compile gives us for, the thing that we did above. We will not do like a big program just because it goes on for too long. What we can see here is that it does, all it does is it will generate a main program that takes the tape, that creates a tape, that creates the head, and then inlines all of those calls, all of those function calls. So instead of interpreting on the fly, we generate a program that is specialized for this. Of course, this will only work if we know the input ahead of time. But because we're writing a Brainfck compiler, a requirement is that at compile time, we kind of have to know what we're compiling. Oh, actually, I made a little error here. I'm just seeing. Oh, that was not great. All right, so that might have been actually what caused the highlighting problem. Huh, fun. That makes more sense. I have to reload, and all right, that looks better. But yeah, so other than that, this is what this will do. And a little thing that I have to do here is I have to eval, because this is a top-level definition. I have to actually eval. Otherwise, if it's just a macro inside of other code, this would work just fine. But because it is evaluated, because it's at the top level, sorry, I'll have to put it into eval. And that's a little confusing, I understand, and ideally that wouldn't be necessary. But what we have now is we have a main function, and we can actually build and run the thing. And if we do that, well, we have an executable. So technically, we've already built a compiler. And if you look at this, without the loops, of course, but if you look at this, this took us a whole 10 lines of code, just because we knew how to build an interpreter, and we just folded it inside out, and what we have is a compiler. Now, this works with a lot of languages, surprisingly. If you have an expressive enough source language and you know how to generate, if you know how to generate code for it like that. But maybe at this point you might be wondering how we would write something like loops that it is a little bit less trivial. I mean, honestly, like, this is a great parlor trick, but it is a little bit trivial. But loops aren't actually a deal breaker here. Neither would be even higher level concepts, but they would make it a little bit harder to manage. And honestly, the macro system would probably get pretty slow expanding all of this at some point. But for simple Brainfck programs, that we can still work with that. And I'm just going to try and implement loops now with you. All right. So the first thing to add is probably this. But if we think about it, there's something annoying about the map here, because it's going to give us one character at a time. What the loop needs, though, is it needs to know what its body is, and it needs to know where the body ends and that kind of stuff. So what we'll have to do is we'll have to feed compile_char the rest of the string. And to do that, we'll have to probably write that a little bit differently. So I'm just going to factor this out right here. Oh, that was a little bit too much. I'm going to factor this out. And what we're going to do here is we're going to write another dynamic function that we're going to name compile program that takes in a string. And it's going to just do basically a map, but manual. And as I said, ignore the green. That's just me having a little bit of problems here with my highlighting. But if the string is empty, what we're going to do is we're going to just return an empty list. And otherwise, what we're going to do is we're going to cons compile_char, let's say, with string. Actually, we don't need this at all. String head s to compile program. As you can see, I'm working on a German keyboard, and sometimes an umlaut gets in the way, with the string tail of s, and that should do the same thing as it did before. So let's just try that out real quick with compile program s and do this. And actually, we erase that line for now, and give this the right thing. Of course, taking string tail here twice is maybe not the best, but we're just playing around at this point. So if I reload here and compile again, okay, so this already changed the type. Interesting. But other than that, it didn't do anything. Oh, I know why. That's just because what we're doing here is we're ending it with an empty, with a void expression. Okay, so we already know how to do this. Compile program. That's probably going to help us for a while now. But what we're going to do now is we're going to, think about how to compile a loop. And the first thing that we need to do is we need to figure out the end of the loop. And I'm just going to say search matching bracket in S. And I'm going to give this a depth. I know that I will need the depth, so I'm just going to give it to it now. In a moment, this will make more sense. And then I'm just going to say body here, and then we'll end that for now. Okay. And then def and dynamic search matching bracket will take that string and the depth, and we'll check if the string is empty. That should be an error, really, but who has time for that? Or the depth is 0, then we're going to return, actually, we're going to return 0, because that is the index of the thing. Otherwise, we're going to increment. What are we going to increment? We're going to increment, well, search matching bracket with the tail of the string. Yes. And we're going to search through that string a bunch of times. So this is going to be, well, a little bit slow, I guess, but it doesn't really matter, because I think if we were to do it now or fix it now, that would be kind of a premature optimization. So we say string head, and that is gonna, is it gonna return a string or a character? A string. So if it's gonna return a string, then if that's an opening thing, we need to increment the depth, because we're in a loop inside a loop. And if it's a closing bracket, then we're going to decrement the depth. If it were just a search that were linear for the next closing bracket, this whole function would be much easier, of course. But it is what it is, basically. But yeah, so what we have here is if the string's empty, which conceivably should be an error, really, or we've reached a depth of 0, then we return 0. And otherwise, what we're going to do is we're going to increment the index every time, because we're going through the string, and we're going to work on that depth with the current thing. Oh, actually, I need to add an else branch, which is if we discover anything else, it's going to stay the same. Cool. So we know what the end is. And now we need to just build a body. And again, we can have that function body here. And the quasi-quote with while, and actually, yeah, while not 0, array unsafe ends. That is, again, like get the thing under the current tape value. So that would be tape head. Well, that is not 0. Execute the body. We don't know what the body is, but we do know where it is. So what we can do is we can just use compile program again. We know the rest of the string, but we don't take the whole rest of the string. What we're going to do is string prefix, which is take a string until, basically, an index, which is end, and I think dec end, because we take the index of the closing bracket. Oh my. There is probably a bunch of off by 1 errors in there, but you know, such is life. Okay, so we have that now, and there is an off by 1 error, but not in that, but in this. Did I do? Oh, actually, this needs to go here, and this needs to go here. Yeah, there was an off by 1 error, not in end, but in parentheses for now. All right, so we have that. Now, with that out of the way, we already know how to compile loops. But what compile program doesn't know is that it can just, after it's treated a loop, what it's going to do is it's going to emit the loop body right after it again, because we only advanced our compiler by 1. So what compile char is going to have to do is it's going to have to return to compile program how far it advanced. But first, let's see that maybe in action, what it's going to do. So what this is going to do is it's going to compile it. Oh, actually, I have to reload first. But what this is going to do is it's going to compile the loop just fine, I think. Oh, no, it's not going to do that. But I'm just going to look at macro. Oh, that's because of the while here. Let's see this. Is that going to compile fine now? Yeah, okay. That was it. But I want to see what the main actually looks like. And to do that, I'm going to do some printf debugging. And I'm going to remove the thing. And what we're going to see here is, well, we have the while and we have the array update. That looks perfect. But then we have another array update at the end because it only advanced by 1. And then we have the plus again, and it's going to emit something for that. And then it's actually going to emit an empty expression for the end of the loop, which is actually kind of fine. In Brainfck, everything that is not part of the vocabulary is just a comment. So I could just write text in the middle of my program, and it's going to be a comment. If I were to care about errors, I would probably at least disallow closing brackets, because that is closing a loop that has never been opened, basically. But you know, again, we're not writing safe code here. We're writing a little compiler. Okay, but so we know what to do now. We need to tell through compile char how far we need to advance. And I'm just going to say, well, this will give us a pair, and the length is the car of that pair. Car takes the first element of a list, in this case of a pair. Actually, that's not P, that's pair. And then actually instruction is going to be the cutter of the pair, which cutter is the end and cutter is the second element because it's the car of the cutter, naturally. And what we're going to do here is we're going to const that instruction on, and instead of string tail, we're going to use string suffix, which functions much like string prefix, but the other way around. And it's going to take the length. All right, so compile program is ready for us, but for now, this really won't work yet because what happened here? I think my VI was being weird. Okay, so what we're gonna do here is we're gonna say, well, this is a list, and all of these are just gonna be of length 1. Oh, and that magically fixes my highlighting. Beautiful. That's amazing. And again, through inserting, I broke this though. But now that the highlighting is less broken, this all makes more sense. Oh, okay, but this doesn't work. All right, never mind. And then here, actually, the list is not going to be 1, but it's going to be n, because that's the length of our program. Is it end or n plus 1? Again, there might be an off by 1 error in there, but such is life. But now that we have that, we can probably go here and reload that and see what happens. So is this still with eval? No, this is now with eval. So I actually have something here, read file hello world brainfuck. And hello world brainfuck, well, prints out hello world, but more importantly, it has a loop in it. So we can probably put that into compile, but we probably can't because compile is a macro. Yeah, it won't evaluate read file hello world bf. It's not gonna because macros don't evaluate their arguments. So what we're gonna have to do is we're gonna have to inline this. So it would probably make more sense to make this a dynamic function, huh? Well, for another time maybe. Okay, cool. So that didn't work, but I'm not going to read that traceback. The traceback that I'm going to read is hopefully that one. That makes more sense. Applying car to non-list car pair. Oh, yeah. Well, there's an empty instruction here. We totally forgot about that one. And that empty instruction, what's it gonna 1? And if I now reload, whoops, I just typed this, which will print the whole environment, which you likely won't want. But if I compile this now, long lines freak out a lot of readline implementations. It makes me very wary of readline, but there are too many expressions in the body of the. Oh, this is a while. A while can only have 1 expression, so this needs to be a while do. R, compile, and let's see whether it works. Oh, yeah, it does. Hello world. We have a hello world. So we've just written a complete Brainfuck compiler. Yay us. If we look at the program that is emitted, it would probably be a little bit atrocious, but it wouldn't be inefficient. It works on the array directly. It does all of the things it's supposed to do. It's beautiful. It is not necessarily readable, though. If I do my printf debugging again, and I remove the eval and that kind of stuff. And I don't type environment, but reload. And then, I print that again, macro log. This is the program that we're going to get. It's not necessarily a good program, but it does what it's supposed to. Now, I think this is good enough. What you could do as a next step would implement optimizations. One important optimization that I love to do is, well, a lot of the times, like in the Hello World, but also really in the, where are we? In the Newline printer, we're doing a lot of incrementing just because we're incrementing always by 1. And often we just want to set a variable to 10 or add 10 to it. So plus and minus tend to be clustered. So what you can do is in here, you could look whether this is followed by a bunch of pluses and group them together instead of inc and just saying add 10 to it. And it would make things much, much faster. In fact, if you are interested in that kind of optimization or even JIT compiling Brainfck in a more, in a more traditional way, because right now what we're doing is we're transpiling into a higher language inside the macro system and then hoping that the compiler will make sense of it all. And it does, and it optimizes it presumably pretty well. But what you could do is you could in here, what is this? Sometimes my Vim setup is a little bit weird. But so what you could do here is you could A, do this grouping. You could B, do a bunch of, there are a bunch of idioms around loops that you could work with. And you could, I forgot. I actually forgot the last one. But yeah, so I've done that before, and I would, I have that on my blog as well. It's called, I think, building a JIT compiler, something like that. I'm not quite sure. But something with Brainfck and JIT, because I wrote this language once, CSPfuck, that had a JIT compiler. And it was written in C, so that was a lot more tedium involved here. But basically, what we can do is we can cluster around a bunch of these idioms and just build an optimization. I don't know what people think at this point, whether we have time to implement one of those. Maybe one of the organizers could tell me the lay of the land at this point, or whether we want to explore what we already have, because we actually have a lot.
So I've just posted a link to, I think your blog post was called "Speeding Up an Interpreter."
Oh yeah,
does that sound right? Yes, I put a link to that on the stream. We've got. Yeah, I think we could do another 15 minutes or so if you had a if you wanted to do something on JIT. While we're talking, let's give people a little bit of an opportunity to ask questions. Please do ask questions on the YouTube chat, or if you're on Discord, and then you can help point Veit towards something that you particularly want to see. What are you most interested in yourself, Veit, of the things you could do next?
Well, I haven't done any of those things yet. Ooh. So it's gonna be fun either way. Okay. I think the simplest thing that we're gonna do, so I have done it, but not in this context, but the simplest thing that we can do here is probably do the instruction clustering, where we just say, well, instead of incrementing 1 at a time, we can increment 10 at a time or 50 at a time. But that would also be a great exercise for the reader if people want to play around with an idea like that at home. So like either way, I'd be happy to facilitate.
Okay. So while we're waiting to see if anyone comes in with any questions, I wanted I wondered whether you had either implemented yourself or seen any good implementations of a Brainfuck compiler written in Brainfuck itself.
There is a person whose name escapes me. They have a they've written a compiler that compiles a higher level language to Brainfuck, and have written a bunch of very I don't remember the name. But anyway, they've written a Tower of Hanoi program in Brainfuck, which in itself is fantastic. I used it as a benchmark a bunch when I wrote the JIT. But they've also then written a Brainfuck compiler, I think, in Brainfuck. But it was a generated Brainfuck program, not a handwritten one. I don't think anyone would want to write that by hand unless they have a lot of time on their hands. Yeah.
Great.
I always feel like I already have too much time on my hands writing programs like what I just wrote, but then thinking about writing a Brainfuck compiler in Brainfuck, I realize that there is no such thing as too much time.
Well, you've got to have a hobby in lockdown.
Yeah, for sure. All right.
Absolutely.
Did anyone come up with anything? Otherwise, I'd be happy to just do a little optimization so that we see how an easy compiler optimization.
Yeah, I think that sounds great. And obviously, if anybody is in the middle of writing a question, then please carry on, and we'll ask it at a suitable point in a bit. But a little bit of optimization sounds great.
Cool. All right, let's get to it. So the first thing is we're going to have to figure out how to get there. But I'm just going to see what we have. We might have string take while, but I'm not sure. Or list take while or something. No. Beautiful. Whoops. What's that? Take. Well, yeah, but I need a predicate. All right. So I'm not sure we have a thing that gives us a take while or something like that. So we'll have to write it ourselves. So that would be a nice first exercise. Because it's in dynamic land too, we don't have to worry about types or lifetimes or anything like that. So it's beautiful. We can just take that. And I'm not going to generalize right away. We're just going to say, okay, get cluster, let's say, and we're going to have the S and the character that we're going to want to look at. And let's say if, you know, the head of the string is equal to character, then what are we going to do? Well, we're going to get cluster. That's somehow very familiar to me right now. String tail S. Of course, if you had a if you had a function like take while, you could express it in here. But I'm just going to do it like this right now. And then maybe we can make it even prettier. And otherwise, the cluster size is 0. So now we already know how to get one of those clusters. And what we're going to say here is, so let's cluster the get cluster with the S and character. But we know that it's at least 1, so we're going to just increment that number. We could do that in get cluster and say the cluster size would at least be 1, but why not do it here? That leaves get cluster uncluttered with any of our assumptions. So what we can do here now is, instead of saying inc, what we're going to say is plus, and we're going to say cluster. As you saw just now, sometimes I tend to do it in the Lisp style with the comma, but then I remember again what we're working with, which is Carp, my favorite Lisp but still sometimes I get dragged down into, I don't want to say inferior. Every Lisp is created beautifully, but you know. All right. So now with that cluster out of the way, what will happen here?
So Veit, there's a question for you.
Oh, yeah.
You said not every Lisp is created equally. How do you feel this whole process of creating Brainfck was different, writing it in Carp Lisp as opposed to, you know, Clojure or Emacs Lisp or whichever other Lisp?
Well, the interpreter part is probably relatively similar, except there is more tedium in Carp. But what the tedium buys us is that we can write, by writing a macro that just spits out Carp code in the end, we can have a static executable. And virtually just taking what we wrote for the interpreter and pushing it out as Carp and have a static executable for free, which is cool. That's also not one of the focuses of Carp at all. It is a focus of something like Racket, where you build languages in the language, but it is cool that you have that Lisp, but you also have the ability to write super dense, super optimized code, if that makes sense.
Yes, yeah, and that was, I think that was the feature where Sam early on the stream commented nice as well. So that was quite a sort of spectacular moment, I think. So that falls out of Carp's features. You're saying?
I think so. Just because I mean, I can compile a Carp executable so easily that anything I can compile to Carp can also create an executable just as easily, if that makes sense.
Yeah. Oh, that's really interesting. Thank you.
Sure. Okay, let's see whether this program actually does what it promises. I have to reload, and then we're going to compile this program again. Oh, we're not going to compile that program. We're going to macro log what it does. And it actually does what it's supposed to do. It's going to increment by 10. Oof, that was on the first try. Hi. I don't know whether you were excited by that, but I was excited by that. That never happens, getting something right on the first try. All right. See, I'm not getting everything right on the first try. Okay. Byte int. Oh, yeah. Whoop. Let's see. Cool. We have to make this actually a byte. Ay. Okay. Byte from int cluster. And then we do the same thing here. So I guess we didn't quite, make it on the first try, but almost. So reload this, try it again, build, execute. Works. Beautiful. Cool. All right. I don't know how much the speed up is for a bunch of this, but it will create way more dense code. So I don't know. I can't remember what the program looked like before, but we can look at it again. I'm just testing whether it works still. It does work still. That won't work, but this will. So if I just say macro log here, ignore the weirdness of the terminal here. Oh, I have to do that, and then macro log. Well, it's still long. Don't get me wrong, but it does all of the optimizations here. 10, 8. It increases a little bit. It decreases a little bit in size. Hopefully at the end. You could probably measure it in the size of the resulting binary as well. I'm not quite sure how good the compiler is at putting these things together, or whether we'd have to do that manually. Cool. All right. We could, I guess, do the same thing with the clusters for our forward and backward. but I think you get the idea, right? Yeah, so I'm gonna just do this. Cool. So forward and backward could be grouped. I don't think period or minus could be grouped, and I don't think the looping could be grouped. But there are some other idioms that you can look into if you're interested in that kind of stuff. There is, for instance, the idiom that will clear a field, because that will just increment until it hits 0 again. And the same thing happens with the minus here. So all that does is it will clear a field. So you could just, for something like that, you could just emit set whatever is currently under the tape head to 0. And that would be way faster than decrementing 255 times at worst, or at 254. Yeah. So I guess that would be something to look into. And then there are some other idioms that I go into if you look at my blog post. Yeah, but other than that, I think that optimization went way quicker than I thought it would. But that's about it. That's all I have, I think.
Brilliant. That's been really interesting. So I think I was always a lot more scared of Brainfck because of the kind of it looks impenetrable, looking at all the pluses and dashes and whatever. Yeah. So looking at that code, it's obviously not idiomatic Lisp code. Is it the most optimal code for a kind of theoretical Turing tape-like machine?
I think so, because back in the day when Alonzo Church came along with lambda calculus, and then Alan Turing came along with the Turing machine, that was basically, in my mind, the first divide of the functional versus the imperative in a way. And so if you want like a cool thing that you can implement at that foundation of programming that you can implement in a very nice and functional way, then you go for the lambda calculus, which a lot of functional languages use as internal representation or intermediate representation. And then if you go for something like something imperative, the heart of imperative programming, then you go for something like the Turing machine, which I think for me, it says a lot that the basically boiling down functional programming yields such elegance versus boiling down imperative programming, and you're left with, well, brainfuck.
Yeah.
Yeah. So I think that's basically it. So if you implement brainfuck, you can implement it in a very functional way. The interpreter that we've written above could also have been a reducer that goes in over the string and works with reduce and that kind of stuff. But it wouldn't have been so true to what you think of when you think of the Turing machine, I think.
Definitely.
Yeah. But alternatively, especially if you don't have loops, you can just take that case expression and put it in a lambda, and then just map over or reduce over the inputs stream, over the input string, with the tape in the head as the accumulator of the reduce, and then you're done. If that
So
makes
that's
sense.
interesting, the way that you can take a very functional approach to implementing imperative code and also vice versa.
Yeah. I don't know whether you've noticed, but with many of these helper methods, I went out of my way to make them recursive functions rather than functions that reset things, just because I find them way easier to think about that way, even though it's such a weird imperative problem. I like knowing where the stop condition is, like where my recursion ends, that kind of stuff.
Mm-hmm. And it's always interesting watching people live code and doing some live coding on streams for LambdaLounge, and I think seeing the confidence with which you came out, and obviously you've kind of practiced and studied this beforehand. But do you find it easier to kind of write code that works, first time, second time, third time, in a functional style?
Oh yeah, for sure. With macros, you have the problem that when something goes wrong, it probably, like, so much could go wrong, and it usually is a little hard to debug. So I'm happy that we didn't run into any big problems today.
Mm-hmm.
But the functional nature of the problem makes it much easier to think about these things and to reason about them. It's almost, if you think about something like search matching bracket, if you understand the condition that is not the base condition, that is already the brunt of the problem. The rest is just, the skeleton of the function almost.
Mm-hmm. And so I suppose the only kind of debugging concern that you had, which seemed more imperative, was a few times you mentioned off by one errors. And I often find when writing in a functional style, you don't totally remove those, but you reduce those. Was that because of the problem space you were looking at?
I think, because we did a lot of string handling. And then if you do substrings and stuff, it is really hard. Do I go after the delimiter or before the delimiter? That kind of stuff.
Mm-hmm.
I find that really hard to think about.
Yeah. Absolutely. It's a comment from Sam. In my experience, functional code lets you keep less in your head and more on the screen. Yeah, that's nice.
That's a nice way to put it. I don't know whether. So that I guess APL isn't strictly a functional programming language; it's a thing of its own. But there is someone who implemented a compiler for APL in 17 lines of APL, and it runs on the GPU, and it's beautiful. You can fit it on a T-shirt. So fitting things on the screen is definitely a concern there. But if the other funny thing about this is, and that's also true for functional programming, I found in general, if you look at the Git history for those 17 lines, I think the additions and removals of lines is like 1 million. Like every line has been touched like 50,000 times. And I feel like that is also very true for a good functional program. I touch every line much more often, and I think about each individual line much more often.
Mm-hmm. That's interesting. That could almost make a talk in itself, I think, sometime. Well, so I think we've come to probably the end of our time tonight. So thanks again, Veit, for coming and talking about Brainfck, about Lisp, about Carp with the Lisp that you are a core contributor to. It's been very, very interesting. If anyone has any more questions for Veit, he is available on our Discord server, which is linked, I think, from the YouTube post, and on the Gitter for Carplang, and you can also leave more comments on the YouTube video as well. And so yes, if anybody has any talks they would like to give for future LambdaLounge, then please do get in touch. We're always willing to host new and exciting talks about programming languages in general, especially functional ones. So thanks very much, everyone, and good night.
Thank you for having me. Good night.